Hello, my name is Ezequiel Linares, and I worked on developing a feedback system for the Proton Accelerator at Gettysburg College. The software that I used was LabWindow CVI, which was a step up from the previously used Arduino software because it provided a wider range of tools and improved functionality. This 250 kiloeV Van de Graaff proton accelerator is used to study low-energy particles like protons and their damage on satellite coatings made out of PDMS. It is important to have control of the charge put on the belt because then you are able to control the voltage on the dome. There is no feedback system on the proton accelerator built in, so I had to create my own using the PID algorithm. I wrote my code in the programming language C. I used the PID toolkit in Lab Windows to create my feedback system. I used the circuit illustrated on the left to create the load which would represent the proton accelerator. The PID parameters acted on the analog output, which was then sent into the circuit, and the dome voltage adjusted so that it got closer to the set point which was given. The triac circuit shown to the right was used later on in the project. The way the triac works is that it only shows some fraction of the AC circuit depending on when the delayed pulse is read. In the first part of my experiment, I wanted to see how stable and how quickly my feedback system could adjust. I started off by keeping a constant value for the I parameter. I then increased P to 0.08. I varied the set point multiple times and saw that the initial change was very unstable. After doing this, I kept a constant P value at 0.3 and then I varied I to a higher value of 0.003. Again, I varied the set point and found that there was a very slow response rate from changing this value of I a very small amount. After trying multiple values for P and I found that the best values were 0.30 for P and 0.001 for I. Doing so, you can see on the left graph that there is a quick response rate along with a very stable change. In the graph to the right, I had the set point value set to 3 for the entirety of the measurement, and I also had the P and I parameters of the previous graph. I found that when I decreased the load on the potentiometer, then the process value increased and the output value dropped. Whenever I increased the load on the potentiometer, the process value would decrease and the output value would increase. The second part of my experiment was to create the delayed digital pulse that would trigger the triac to turn on. On the figure shown to the left, I show how there is a delayed pulse in the blue relative to the function generator wave in the yellow. I still need to make some adjustments to the timing of the digital pulse because there are some cycles when the digital pulse does not show up. I was able to create a working feedback system using Lab Windows. I found that the best values for P and I were 0.30 and 0.001. I was also able to create the digital pulse which was triggered by the rate assigned from the function generator. Something else I need to work on is on the timing for the digital pulse to ensure that the triac turns on when it's supposed to every time.